Welcome back. So now we're looking at right angle word problems. Two situations you have to learn here is one is an angle of elevation or inclination. Inclination. I think that's right. I'll check that up in just a little bit. But it's the angle of elevation is what you'll see most, and an angle of depression. An angle of elevation, elevate, to go up, means that it's the angle up from a horizontal. Up from a horizontal. Can I say that one more time? Elevation, up from a horizontal. Angle of depression. No, it's not a sad angle. Ooh, it is the angle that goes down from a horizontal. Depression, depression, down from a horizontal. So we have an angle of elevation going up from a horizontal. We have an angle of depression coming down from a horizontal. Where the horizontal is doesn't really matter. It can change depending on the situation of the question, but we have to remember up from the horizontal and down from the horizontal. Example 1. We have a photographer that wishes to take a picture of a bird in a tree. So she is going to be 15 meters from the base of an 8.3 meter tree. What is the angle of elevation? Now, we need to be clear when we're drawing these diagrams because sometimes pieces of information are important and sometimes they're not. So here is one particular way I could have drawn this. Here is my tree. Here is my bird. That is a bird in a tree. Here is the ground. Here is my photographer. The photographer is looking up at the bird. The question is, what is the angle of elevation? So the real question is, where's the horizontal? In this particular example, the horizontal is here. Notice it's parallel to the ground, and this is my angle of elevation. Now, in this particular question, the height of the photographer isn't taken into account at all. What I'm getting is the height here minus the height of the photographer. That might be important in the question, it might not. If they tell you that the photographer is 1.5 meters tall, then you know that the bird is going to be an extra 1.5 meters off the ground from this diagram. Now here's another way we could have drawn the exact same diagram with almost all of the same information. There's my bird. Good looking bird, eh? And here's my ground. And here's my photographer. I draw my photographers like I draw my birds. They look good, don't they? Here's the difference. That's my looking up at the bird. So my angle of elevation is taken from a different horizontal. In this case, the horizontal is the ground. It's this angle. But notice, do you see this angle here? If I was to bring this down like this angle here is going to equal this angle here. They are the same angle. The difference is we don't care about the height of the photographer in this one. Has nothing to do with the problem. We know that when we get the overall height, we're going to have the height of the bird in the tree, regardless of how tall the photographer was. So we need to pay attention to the question. I have a photographer. They want to take a picture of a bird in a tree. She's 15 meters from the base of an 8.3 meter tree. What's the angle of elevation from the photographer to the bird? Nobody cares about the photographer's height. So, here's my tree. Here's my bird. I'm really good at drawing those, aren't I? Here's my ground. Here's my photographer. Again, looks an awful lot like my bird. I'll put a P so you know the difference. I'll put a B so you know a bird. And why don't we say, this is going to be the bottom of the tree. I can't use bottom because I use B for bird. So why don't we use T for tree? So that's the bottom of the tree. That's the base of the tree. Now we're going to put in some numbers. She's 15 meters from the base of the tree. Oh, there's the base of the tree. That's 15 meters. And the tree is 8.3 meters tall. There's 8.3 meters tall. And we're going to assume that trees make a 90-degree angle with the ground. Yes, I know that's an assumption, but we're going to go with it for now. Looking for the angle of elevation, it's got to be from a horizontal. This is the line of sight. The horizontal in this case is going to be the ground. That's going to be theta. Now, there's a new concept for you. Theta. That is part of the Greek alphabet. We use it to represent an unknown angle measurement. I could have called it angle P, but I didn't. There's another unknown angle symbol that we used, and it's called phi. It's also part of the Greek letter alphabet. We use both of them in mathematics. Don't be confused by them. So I want this angle. From this angle, notice that this is my 90, so this will always be my hypotenuse. For this angle, this is my opposite. For this angle, this is my adjacent. So I've got opposite and adjacent. I want an angle, so that's going to be tau. So tangent of theta equals opposite 8.3 over 15. But notice that this is an angle that you're going after. So that means that we need to do the inverse. Angle theta is given by the inverse. Now that's all one symbol. That's not an exponent. 8.3 divided by 15. So 8.3 divided by 15 equals second function, the inverse of tan, and I get an angle of 28.9572176. Now, it hasn't told me what to do in terms of rounding. Let's assume that it said round to 1 decimal place. So I go to the 5. The 5 says to round the 9. The 9 goes to a 10, leaving me with 29. But you put in decimal 0 to show that it's accurate to 1 decimal place, that this 9 actually changed to a 10, and we know that. You don't just show it as 29 if you're rounding to 1 decimal place. Round to 1 decimal. Now, if they didn't tell us how to round, you can do whatever you want. And they didn't, but for this example, we're pretending that they did so that we can have this discussion. Okay, we'll stop there and I'll be right back.